Okay, fourth graders, today we're combining two lessons, Module 5.22 and 5.23. Both lessons are about using pictures to help us add, subtract, and multiply fractions. Let's first talk about the problem of the day. It says, Winnie went shopping and spent 2/5 of the money that was on a gift card. What fraction of money was left on the gift card? Draw a number line and a number bond to show your thinking. So this question is asking us to use a number line and a number bond to figure out what fraction of the money was left on the card. Okay, and we know that she already spent 2/5 of the card. So if we use a number bond, we know that she had one whole gift card to start out with, right? And she already spent 2/5. Well, instead of thinking it as one, we can think of it as how many fifths? 5/5. Good. So if she spent 2/5 out of the 5/5, how many fifths are left? Are enough? 3/5. So the answer is 3/5 of the what? Good. How can we show this using a number line? Go ahead and talk to a partner and show them how you used a number line to show this. Okay, today for our first slide, the directions tell us to draw a tape diagram that matches the number sentence and then solve it. So our first question is 2 plus 1/4. If I draw a tape diagram, I can show that I have 2 first, and I have to add 1/4. All together then, what do I have? Everyone? 2 and 1/4, and we write it like this. It's a mixed number. 2 and 1/4. Good. Now for our second one, we have 2 minus 1/5. So again, I'm going to start out with 2, but what am I doing this time? I'm taking away 1/5. Hold on. I'm going to redraw it. This part's not 2. This part is 2 minus 1/5. Right? So I'm going to start over. I'm going to say that I have 2, but instead of labeling it inside, I'm going to label it on the outside. I'm going to show that all together I have 2. And then I want to take away 1/5. I'm trying to find out what part is here. Does that make sense? So I can think of 2 as 1 plus 1. Do you guys agree? Using a number bond? Now if I want to take away 1/5, do I have to take away from both ones or just one of the ones? What do you guys think? Everyone? Okay, so instead of this 1, could I think of it as 5/5? Yes? And then if I want to take away 1/5, how many fifths are left from that 1? Everyone? Okay, so so do you guys agree that 2 is the same as 1 plus 4/5 plus 1/5? Is that equal to 2? Yeah? And if I want to take away 1/5, what do I have left? Everyone? 1 and 4/5. Very good. Here we have 3 numbers, 2 sevenths, 5 and 5/7, and 6. These numbers were not randomly selected. They fit together in some way. See if at your table group you can work with your table group mates to use the 3 numbers there to write 2 subtraction problems and 2 addition problems. Does that make sense? They're a fact family. Figure out how can those numbers fit together and write 2 subtraction number sentences and 2 addition number sentences. Then draw tape diagrams or number lines to prove it. Go. Okay, so right away a lot of you guys saw that it fits together like this. Your tape diagram should look like this. Because 5 and 5/7 plus 2/7 equals 6. There's one addition problem. Another addition problem could be 2/7 plus 5 and 5/7 equals 6. What property tells us that those two problems are equal? All I did was move the digits around, right? Yes, Garrett. The commutative property, very good. How could I write a subtraction problem? Well, I know I have 6 altogether, and if I take away 2/7, I get 5 and 5/7. Another division problem that this tape diagram shows is that if I have 6 altogether and I take away 5 and 5/7, I'm left with 2/7. All 4 of these number sentences are represented by this tape diagram. In your notebook right now, make sure you have this tape diagram written down, and then tell each other at your table groups how each one of these 4 number sentences can be shown on this tape diagram. Now it tells us to solve using a number bond. Okay, and then we have to also draw a number line. So basically we're using a number bond and a number line to show each problem. Our first question is 8 minus 5/6. Okay, so if we have 8 altogether, we're subtracting a fraction. And when we subtract a fraction, I like to think of taking it away from 1, right? So I like to first think of 8 as 7 plus 1. Do you guys agree? Right? But then I like to think of this 1 as 5/6 plus what? 1/6. Because that way, if I know I need to take away 5/6, I know I'm left with 7 and 1/6. Does that make sense? Okay, so the answer then, of course, is 7 and 1/6. Because I separate out the 7 and the 1 first, because I know that if I'm taking away a fraction, I just have to take it away from 1. The rest of those holes, I don't really need to touch them. It's fine. Okay. So if I use a number line, here's what it would look like. I don't need to start at 0. I'm going to start at 8, and I'm going to have 7 here, and I'm going to have 6 here. And each of those holes needs to be divided into sixths, right? So there's 6. Now if I'm going to take away 8, I'm going to start at 8, sorry. I'm going to take away 5/6. 1, 2, 3, 4, 5. I end up right here. So on the number line, I can see that that's greater than 7. How much greater than 7 is it? 1/6 greater. So the answer is 7 and 1/6. I'm going to label it as 7 and 1/6. Okay. Let's use that same logic to help us solve the next problem. Let's use a number bond first. I start out with 3, but I'm just subtracting a fraction. So what should I take? How should I separate out my 3 first? Using the same logic. Kaship?
7/8 and 1/8.
So 7/8 and 1/8 are my 2 parts of 3?
Wait, no.
Okay, you made a wonderful, fabulous fill. I do want to get to when I'm thinking of 7/8 and 1/8, but not yet, because 7/8 plus 1/8 does not equal 3. What does it equal? Everyone? 1. So before I get to this step, you skipped a step, Kaship. We have to back up. Kaship, help me out. What do I have to separate 3 into?
You need to separate it into 7/8
7/8, okay.
and
This is exactly what we wrote before, 7/8 and 1/8. What does that equal to? 8/8, which is 1. We're trying to make it equal 3. So again, you skip steps again. We don't want to skip to the fractions. First, we have to separate out one whole from the rest. So we have to say we have 2 and we have 1. But this 1, instead of thinking it as 1, we can think of it as Kaship has said many times, 7/8 and 1/8. So really what we're saying is 3 is equal to 2 plus 7/8 plus 1/8. Do you guys see that? And then we have to take away 7/8. So we're left with 2 and 1/8. Good. Use a number line to show that that's true. Go. Okay, so if I start at 3 and I take away 7/8, I have 1, 2, 3, 4, 5, 6, 7, 8, and I end up right here. Well, that's 2 and 1/8. So I get the same answer using the number line or using the number bond. Our learning goal says we need to use pictures to add and subtract, which we've done, but also to multiply fractions, okay? And so I'm going to show you how you can use a number line to multiply fractions. We know that multiplication is the same as repeated addition, right? So here we have 6 times 1/3. That's the same thing as 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 plus 1/3 6 times. Do you guys agree? But we also can use what we know about math. We know that 3 times 1/3 is what? What? 3/3 or 1. So I can think of it, instead of thinking it as 6, I can think of it as 2 groups of 3 times 1/3. Do you guys agree? Right? And 3 times 1/3 is equal to 1. So this is really 1 plus 1. So on a number line, I can show that 3 times 1/3 is 1, and then 3 times another 1/3 is 2. So I can think of this as 6 times 1/3. Instead of 6 times 1/3, I can say this is 2 times 3/3, because I have 2 groups of 3/3 here, which is, of course, equal to 2. Does that make sense? Let's try it with another example. So I have 8 times 1/4. Okay, so in my head, I already know that, let's think about it. What times 1/4 will equal 4/4, which is 1? How many copies of 1/4 do I need to make? Everyone?
4.
Okay, so I can think of this important fact in my head. So on my number line, if I start at 0 here and I have 1 and I have 2, etc., if I divide this into fourths in between each whole number, I know that moving from here, 0 to 1, is the same as 4 times 1/4. Do you guys agree? And then moving to 2 is another 4 times 1/4. And if I make 2 copies of 4, that's 8 copies, isn't it? So using numbers, I can write that 8 times 1/4 is really 2 times 4/4. Do you guys agree? Which is what? 2. So my answer is 2. When you see these problems, especially when the first one has been done for you, copy exactly the same pattern. You can see here they used the original problem. So first, I wrote the original problem. Do you guys see that? Then I modified the problem based on what I know in my head, that 4 times 1/4 is 4/4. Okay? And then came the final answer. So especially when they give you an example of how the problems should be, how the solution should look, follow their example. Okay?